Hello. I am going to start to clean up the enclosure on the bottom part of the box, and just out of my own curiosity, as far as scientific value and for mine and viewer entertainment, you might want to try and figure out what type of electrolyte crystal has been deposited in the inside of the box. Is it acidic or is it alkali? So what I'm going to try to do is I've got most of it arranged into two different piles, and I am going to put some hydrogen peroxide in one, which is an alkali, and see if it reacts to that. And then the other pile I shall take some regular vinegar. Looks to be not really too reactive to the hydrogen peroxide on the left. Don't really see any type of fizzing or any other reaction going on there. I'm going to rinse the eyedropper out with water, and I'm going to put a little vinegar in here. And hard to say a verdict from either one. I don't really see much of a chemical reaction going on either one. The vinegar maybe has a slight one, but also the hydrogen peroxide isn't really acting too differently. So whatever the composition is, acid or alkali, it's not apparently too out of balance on the pH on either end enough to cause a reaction like something like mixing baking soda with vinegar would. But this kind of means I won't risk any bad chemical burns disposing of or handling of it going forward. So off to cleaning the enclosure. Okay, we have moved cleanup operations outside, so I hope the background noise doesn't disturb the recording too much. I'm going to, first off, safety first, so I do have a pair of safety glasses I am going to be wearing, just to make sure that, if anything, I end up with intact eyes out of this. And then we're just going to have at some of the rust here. What I'm planning on doing is to just sand the inside of this lightly after I remove as much rust and corrosion as I can. By a mechanical process, and then clean it all up, prime and or prime paint it. I might use a primer paint combination. One part I wanted to pay definite attention to is the switch housing. Kind of afraid to turn the tool up to too high an RPM because bad things happen when something gets out of control at high RPM with these things. Never fails. And the outsides I'm going to clean up a bit with the wire wheel and sand and then paint that. I masked off the surface as well as I can. Get most of the major visible rust off it. And it's a bit cleaner, but I think I might try something else. I have some chemical-based rust remover. I might just try to dabble on there and let it sit for a bit and see if that has an effect on anything. I'll be back. One thing I definitely want to accomplish is polishing up these rivet heads because these are going to stay on the front panel, so we're going to try to give them a little wire wheel. All in all, I have a feeling that the plating just wasn't too great on those, and I can probably polish them up as steel the best I can and clear coat them. But for right now, that's removed some rust. And we'll pause while I get some rust treatment. So the rust treatment I chose has a working time of 48 hours at 65 degrees Fahrenheit according to the directions, and the items to be soaked in that. And I'm not going to soak it because I really don't want to immerse the whole painted item in there. What I'm going to do instead is going to try to pour some on a moistened towel and just let it absorb and soak in through that, maybe agitating it a little bit every now and then. but I can't see immersing the whole panel in there full time. When something like this should be adequate. I can always check up on it and add more, but at this point, this small amount should be fine. And this is just something I'm going to have to come back and check up on later. And as far as the bottom of the box itself, it has some corrosion on the inside from the capacitors. I ended up just rinsing out the inside of the box with water, and as far as stripping the paint, I'm probably just going to use a brute force angle grinder with a wire wheel cup on the outside. Should be easy enough. It looks like a hammered paint that might be pretty durable, but it should come off. And the inside, I do not have a sandblaster, so I have my choices of heat and a putty knife, or chemical stripping, or sanding. And I'll probably use a combination of one or two or all three. I'm not going to put that on camera because it'll be more work to film than it will do the work, but I'll let you know what I used and show you the results before I start painting it again. I did use a wire wheel and an angle grinder. I was surprised at how well it does work as far as removing this paint, so I thought I'd shoot a quick video. The only thing is, this is a safety absolute to wear good eye protection on this, not just eyeglasses or bare eyeballs. If these wires come off of this wheel, it spins at 10,000 RPM at least, and it will seriously injure. It could even stick into your, one of these could easily stick into your face, but it's not going to damage anything seriously. But if it penetrates your eye, you're going to have a trip to the emergency room that, one, that could have been prevented, for two, you're going to be kicking yourself in the ass for the rest of your life with whatever happened to your eye, asking you why you didn't take the time to put eye protection on. Whenever using an angle grinder like this or an unprotected tool, you have to realize which direction the debris is going to fly off it when you're using it, which directions it might kick back at, and compensate for all of that to try to be as safe as possible. And this is progress for the day. I ended up trying to remove some paint with a torch, and it turned into a odd process that didn't really work well. It really blued the outside of the metal and didn't, as you can see there, didn't really remove the paint well with the scraper. So I opted to use some chemical paint stripper that I had. It wasn't the most environmentally friendly stuff. It's methylene chloride based, but it's stuff that I had already. I did not run out to the store and buy it, and the next batch of paint stripper I buy, I'll probably try to get something more environmentally friendly. It's just not the best chemical to use. Methylene chloride's some pretty nasty stuff in general. And there is some leftover mild corrosion on the inside of this, but I'm going to, before I paint it, I'll give it another little going over. Give it a wash with some chlorinated brake cleaner, and probably prime it with some self-etching primer, and then this will probably get a hammer tone paint to it, something similar to what it had. And then the inside of the cover here, this sat for a little over an hour, and just with this moist paper here, moist towel, would seem to work on some of the corrosion. I'm going to let this sit for probably another day. It should stay moist, and I'll get some more of that, and then I'm just going to sand up the inside of it. But it is helping to remove some of the corrosion, especially around this switch plate here. It's looking a little better. It's looking a little more like clean steel instead of looks like some of the debris is wiping off at this point. So it stays moist overnight, then it should be in good shape, and I'll just have to hope it didn't destroy any of the paint marking on top. I don't think it did. I've got it covered up with masking tape, and it may or may not have gotten wet. And then the edges I'm just going to sand up and sand the prime, possibly paint silver again, or possibly paint spray with the hammer tone, one of the two. So that's my choices for now, but that's my progress for the day, and we're going to stop at that and probably continue tomorrow. Hello, and welcome to part 2 of the Sencore Electro Sub Model ES-102 restoration and modification. It's been a little while. I've had to strip, spray paint stuff, order some parts, order some more parts, because we'll go into that later. But what's happened is I finally have a box that's clean on the inside with used a hammered textured paint. I might didn't do the heaviest coat on the outside. I can recoat that when I'm done. It's no big deal. But I'd like to try to make some progress in the meantime. I did get the cover cleaned up fairly well. I clear coated it. Had some scratches on the side, so I spray painted it with some nice sparkly silver paint. It's actually a fairly good paint because along with the metallic, it's got a clear built in with it, so it gives some protection. And I did manage to clean up the metal corrosion as well as I could on my switch cover and stuff inside. I'll show you how that came out. It actually came out pretty good with that that rust dissolver that I used. And this will be the unveiling of the painted area here. It was a little bit of a bear to mask off. But the switch housing itself came out really fairly clean. I'll get the last piece of tape off it, but you can zoom in a little here. You can actually see the Underwriter's Laboratory inspection marking in the switch. It's only rated for 5 amps at 125 volts, but it's there. As with a lot of things with switches, things are used outside of their rating for applications in some devices because they're just, nobody's going to design a switch to do certain functions that are just put into devices like this. So, and I got that nice piece of tape off there, and then I did manage to polish up the rivets fairly nice, and get some clear coat on there. They came out surprisingly good. And I've had some scratches and stuff. I found that the red paint on the cover that they used on Sencore, it kind of bled a little bit when I taped it, and then I used some some chlorinated non-flammable carb cleaner. It did run just a touch. You probably can't see it much here, but It did run onto the tape and things afterwards, but it didn't smear it too bad, so everything's fairly legible. Just if you're going to clean off a cover from a Sencore item, be aware of that. The black paint was pretty stable. I didn't see any of it smudge or anything, but the red stuff, it was definitely able to be dissolved by a chlorinated non-flammable carburetor cleaner, so I can make a note of that. And then my dilemma is how to get the capacitors back in here, how to connect everything and make space for things. I managed to get a source this guy. I don't know if it was on Amazon or eBay, but it was a pack of 5. They are 11 contact switches. I only need 10. It's a single deck. Of course, they are made in China, of course. But the bottom line is, I'm going to put a little bit of cleaner lube on the contacts, and it'll be a lot more functional than the old one, because the old one is just, it's not going to make it. There's no, I tried cleaning this thing even with some Tarnex, and I did get the silver wafer on the metal. I cleaned it carefully with a small swab, some Tarnex, and then rinsed it off, and did manage to get more of the corrosion off it, but this switch is too far gone. It's just because of the fatigue and some of the contacts. Like I said, this one here, it's just, or was it this one? One of these guys anyways, it just wasn't springing back. Maybe it's this one. Yeah, this one just didn't have the spring that it needs to come in and make contact. There's a contact on the bottom too, but those two have to squeeze together to form a good contact, and the fact that I can't clean the bottom of that wafer off easily and the contacts are questionable, it's going to be a problem. So now the thing is, if you notice the space for vertical height on these two switches, there's probably close to a good ½ inch of difference between the mounting, if not more, and I'm going to have to be aware of the fact that I'm putting in a switch that's going to sit deeper into the box when I am installing these capacitors. So I'm going to keep that in mind and start the process of installing the capacitors. So we'll get to that in just 1 minute. In the process of repopulating this box, because of the contamination that was in it from the existing original capacitors, and just to keep things a little more friendly inside the box, I decided to try and line it with some sort of material that would be electrically insulating and also keep contamination, if any of the electrolyte leaked out of the new capacitors. Now, what I decided on is a material that I am used to using in my old job function of installing DC power systems. We were required at times to lace cables to racks on long runs. They were 48 volt DC cables, and they needed to have insulation material put in between uninsulated metal racks where cables were laced to them, and one of those materials was the Nomex based cardboard, and I managed to find some on eBay for not too bad of a price, and I was thinking of lining it with just regular electrically insulating cardboard, but then I just, for the heck of it, I did a test on one piece, and I'm going to try to show you what happens to this stuff here. This is, oop, I dropped it. This is a regular insulating cardboard, and it will catch fire. So we're not going to use that. And then the Nomex stuff is going to behave a little differently. It will combust a little bit, but it is self-extinguishing, so it will not continue to combust for any reason. So it's a good material. It's very durable. It has more definitely more durability than just regular cardboard, and it's just friendlier to use in general. I had good experience with it over the years, or everything I did with it at work. I never really had a failure with it, and I just decided that it would be a nice little thing to add inside the box. It's not too expensive, and yes, I am going overboard on this build as far as restoring it, but I'd like to do that just so when I go to pick this item up, I'm not going to have any worries about its functionality or what may or may not happen if there's a failure inside of it. So going forward with that, I'm going to work on cutting out a piece of cardboard to fit the inside of the enclosure and carry on from there. So bear with me here, I'll be right back. And I was a little bit off on my estimation of the size of the enclosure before. It is about 4 3/4 square from the looks of things. And the depth on it is 2, and it looks like 2 1/4. So that's the size of paper we're going to cut out for it, barring any errors in calculation here. I'm just going to have to get a piece here, map it out, mark it off, and since this is basically arts and crafts time, I'm just going to, I mean, most everybody's done this at some time in their life with something, so I'll omit this little painful part of it, and I'll come back and show you the finished product. Okay, I have returned. I have started my little arts and crafts project and made myself up a boat that has some overlapping flanges to it that fits quite nicely inside of the box. Doesn't overtop it, and what I am now hoping to do is to mark and tape the seams together on the outside of it so it kind of stays stable. So I'm just going to take my pencil, spread these out as far as I can to make sure it's a tight fit, mark it in each spot. This one here, this one's going to be about right there. And then for my choice of tape, I had some leftover tape from household remodeling projects. I have this is it's not a flame-proof tape, but it's a tape used to seal seams in house wrap. I don't know if you've ever used this. It's just got this adhesive that, like, once it grabs, it does not want to let go. It gets stronger over time. The tape, you will have to tear this tape apart to get it to come off of something. It just won't peel off again. It's really tenacious stuff, and I figure it would be, for one, I've got a couple, at least one good roll of it left over, and for two, it's just a good tape, so we'll use that. It's definitely going to hold this together to the point where I won't have to worry about coming apart, or so definitely one and done. And beats going out and buying stuff if you can use stuff that you have around on hand. So it's a little bit of a hard time getting it off the roll even. And when it comes apart, it breaks. It wants to come apart in pieces. It is not friendly for removal at all. Oh. I am trying to fight back a sneeze while I do this. Oh man, just Hoping it doesn't fold back on itself here. There we go. It lined up good. I'm sure you'd probably never see a mass-produced item that's put back together like this. It's definitely would not be cost-effective, but it's like I said, it's something that I like to do, so I don't have to worry about it. Lost the end here. It's here somewhere, I know it is. Found it with my nail. Leave myself a little fold over so I can find it again if I need it. Okay. Oh, I might have left this a little long here. I had to do some resizing when I originally cut this, so just don't want to have the cardboard fighting itself. It looks to be pretty good, so at this point we have something that should get in there and fit fairly well, and it does. Not going to worry about taping it up on the inside because whatever I put in here is going to work on pushing it back out. But that makes for a good containment of things and just makes it a little tidier in my sense. So now the fun part. I have to go through the process of installing the capacitors. Okay, that's the amount of capacitors that I need to put in there. The thing about doing the installation is, for one, it's keeping it like this is not going to be in the original configuration of what was in here. We had, pour these back out just to get them out of the way. We had these Goodman Dynamite Sticks here. I don't know if you saw the last video or not. They have multiple values in them, and they were two of them had 3 different values, I think, and this one has 4, or maybe 2 of them had 4, one of them had 3. And the switch configuration was kind of odd because what it did was it took contacts, 3 contacts, and connected them together at once, and these capacitors were wired with a common negative, and the positives were made so as you rotated the switch it would be connected to 3 different capacitors at one time, except for possibly in, I don't know, maybe one position might have only allowed it to be in one, or the way this deck was wired for the lower value, because the lowest value in here is 4 microfarad. And it kind of added a little complication. I never did find a proper schematic of this device to figure out what was going to be required versus what was originally configured. As for all my connections. And I was thinking of, okay, I can put these guys loose in here. I did secure some solder tab strips, and I was thinking, how would I put these in here, because the box itself isn't quite wide enough where I can put two abreast. I'd have to put like two in a corner or something like this here, and another two there, and it would take up more space in the box, more room that I need for the capacitors and the switch, and it would really make things kind of awkward, plus the fact that I could not secure the capacitors well from physical vibration, being jostled around or anything. So it came to me that probably the best solution I could think of would actually be to take these capacitors grouped as I need them for their values, because they've got 220, 180, I've got various values here. Some of these are going to have to be paralleled to get close to the indicated value on the switch cover. And I also found that a lot of them were, since it is common to rate capacitors for their values as far as plus or minus 20%, it seems like a lot of these were manufactured on the minus side, because this one I measured here, it's got a rating of 220 on it, and this one measured out to 185, and that was going to cause me a lot of grief as far as trying to get an actual proper value on the indicator for the switch. So what I planned on doing after that is to manufacture my own dynamite sticks. I was thinking about that Nomex paper, and I was thinking that all I needed to do is make a outside tube construction out of those, and then I can arrange capacitors as to how they might fit within the needed sizes of the tubes, wire them out, and then I can wire them directly. I can wire the positives directly to the switch for the proper value, making some sort of color code and marking the outside of the tubes as to the values for the colors. And I could also take that tube, stuff it with some fiberglass, and I can make a fairly neat looking interior enclosure that although it's not like I said, it's not a true reproduction of, because I wasn't really heading for that. I didn't want to try to restuff those tubes that were the original capacitors were in, because I have no idea what's in there. I had no idea how well they'd survive, plus the values would be off from mark as well. So I figure that for my assortment of capacitors that I do need in order to connect, in order to populate the box correctly, that I should be able to fit these inside of 3 tubes that will wire and fit within this box, and still have clearance for that new switch install. Because remember, this switch install is going to be a little deeper than the original one, by about a ½ inch, and a little wider as well. Because like I said, I just couldn't get a source of an exact replacement switch for that thing, or something. Possibly could have shopped around for a smaller size, but these were available quickly, and they were lower cost, and from what I've seen from reviews, they did hold up fairly well for people that have purchased them. So we're going to head in that direction. So the next part of this is going to be to measure out what I need for sizes, for diameter that'll fit into the depth of this box, what I can get away with, and then construct something that will hold groupings of capacitors and wire them up, stuff them in the tube with some fiberglass, make some end caps for them, which I'll go into that as I make them, and assemble that back together so we can start doing some soldering and connecting things back up. So we'll get to that in a bit. Hello, I'm back, and wiping off as much of the crustiness as I can off of one of these fine little original devices here. I am going to insert it into the box and see what kind of clearance this has for a reference. I've got the switch mounted, the new switch mounted on the back plate of the panel, and so you can see this is pretty much a no-go. We are probably talking about a size difference of at least, I'm going to try to measure it out with my fine pair of well-used busted up display calipers. I'm going to say 17 millimeters, 0.682 inches, or 17 millimeters probably from where the lid would seat to the overlap on the box. I'll probably say it's a good 3/4 inches. And then also there is an issue where we have these two extra pieces of hardware sticking down we did not have on the original switch, and what that will probably end up doing though is, if you look, it looks like it'll sit in a valley between two tubes, and I can probably, if I put this off to the side, I don't think that hardware will interfere with it. Now the only thing is that if I rotated this so it hit the middle, then I would have to have a really reduced size on the even more so reduced size on the capacitor in the middle, and but I wouldn't risk hitting the other ones. But in this case, this looks like it's going to sit in the valley between the other ones, so I can more likely than not think that this will let the lid fully seat without any interference. And we might get some minor interference from the soldering connectors on the switch itself off to the sides. But let's see what we got here. Kind of made life a little harder for myself because I sprung these side panels out a bit to paint the exposed edges. They weren't this wasn't a solid seamed box or welded seams or anything. These things were turned out pretty fast from the looks of it. So got this darn thing together somehow. I had it together a minute ago. Okay, got that. Okay, we're good to go, and it looks like it's fully seated without any interference issues. So it's, I think what will happen is I can probably create something that will let me have two capacitors of a comparable diameter on the outside, and I just have to downsize the existing center capacitor by 3/4, and I think I could do that because I think with the tube sizes some of these will hold some larger capacitors without a problem. And I can probably gang some mid to small size ones because some of the other ones are very small in diameter, half inch or less, and I should be able to gang those up fairly well in the tube. And I can make a color-coded wiring array and mark the outside of the tube with a label maker just to let people know what type of capacitor and what value are in there. So if anybody, I can imagine this will probably outlive me, so it'll probably end up in somebody else's possession, and or maybe even someone else's estate if it outlives them too. But it'll be something where somebody can understand what's inside those do-it-yourself dynamite sticks, and also I'm going to manufacture them with some hot melt glue, so it could be re-enterable if the need be. So, boy, I just even just handling it there, I thought I cleaned it up enough, and yet more stuff came off them. So, so at this point, we're going to start to figure out measurements for what I need for the cardboard and make up a few tubes. And we'll get into that in a little bit. I am going to plan on making the tubes for the new capacitors a little shorter than the original ones, just to give me a little more wire space to have the leads come out of the top and not be such a drastic bend on them. And these guys measure, there's a 3.715. So what I'm planning on doing is I will probably make something that is about 3.7, that would be 3 5/8, or 4 5, no, it's got to be 4. What did I do here? I'm not zeroed. Okay, here we go. 4.7. I am here now. 4.6. If I cut my cardboard to about 4.5 inches, and what I'll do is, in the process of rolling up the cardboard, I'm going to need to cut, make little strip cuts in the edges of both ends of these, so I can fold them over on top of a plug and glue them with some hot melt glue in order to hold the end caps in. It'll shorten it. If I make, like, let's say if I make those 1/4 inches or so, it'll shorten it by another 1/2 inch, and that'll give me enough clearance. I mean, these had some clearance with the leads pressed down in them originally in the wax, but I'll leave myself even a little more clearance, and I can always fill that in with some fiberglass insulation or something, just to keep them from rattling around. But it will give me enough space, I think, to get all the groupings of the needed capacitors in here, because, like I said, we've got 10 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and most of these are going to need to be grouped in parallel to get the close to a measured value that matches the marking on the screen. I found, like I said, that a lot of the capacitors I bought, they were rated for plus or minus 20, and quite a bit of them, especially the larger ones, were close to 15 to 20% under value. So whether that value would change over time with usage, I don't know, but the thing with these capacitors is they will not be sitting in a circuit used too often. It's basically just going to be for a quick test configuration to get something working, or to find out if adjustment needs to be made in a device that will give it better operating conditions. So we'll go from there. Okay, I'm going to work on the math for doing, I did work on the math, but I'll go over it with you for making my dynamite sticks here. I need the 2 sticks on the outside to be 1.5 inches in diameter, and in order to turn the length into a diameter, of course you got to multiply your diameter by pi. So 3.14 equals out to 4.71 inches. We're going to call that close enough to 4 3/4, which, funny enough, is also about the same length of the dynamite sticks that were in there. It was almost exactly. So I measured that off, and then what I'm going to do is take these pieces, and I'm going to make up 2 of them, and I'll do the third one on the camera later. But I'm going to make these up. I'm going to put them together with some non-flammable contact cement, and then tape the outer seam. And I think 2 layers of this material with that contact cement should give me a fairly rigid tube in order to install capacitors in. And like I said, 2 of them of a larger size should be able to install by larger values that have larger size configurations in them. And the smaller ones, some smaller ones can be put in a middle one. That one will probably have to do something about about a 3/4 inch diameter tube. But between the three, I should be able to get those all in there, contained in a way that they're marked, and they look fairly organized when not too much different from when it was manufactured, except it's going to be just a homemade DIY configuration, which won't be the worst thing. So I'll get to working on that, and I'll show you me putting the last one together out of the deal here. So, hi. Going forward from here, things are going to get exponentially messy, I think. I've got my can of Weldwood permanent on-bond contact cement, non-flammable, and this is going to be what I'm going to choose to try to get things put together in a way that'll be a little more indoor environmentally friendly to handle. I'm just going to have to hope that things don't get out of hand. I've got my pieces of cardboard cut to size, and I've shaken my can a bit to try to mix up some adhesive as well as I can. So we'll see what's happening here. It's at least things are room temperature, so it's always a good thing. I guess the object of this is just going to be to try to form as rigid a tube as possible out of a couple of 2 layers of this insulating cardboard. I'm going to apply some of this to the what's going to be the inside of the first layer. And as I go here, I'm going to hope that sets up fairly fast. I should probably get a hairdryer handy or something. I've got a line marked where I need to join my 2 pieces together in order to have them be a 1.5 inch diameter. And my goal is going to be to join them at that mark with the tape sticking to my glove. I'm going to take one of these gloves off. I'm trying to not get the contact cement on my hand, and it's going to complicate things just to have everything stick to the glove first. So this part of the process, as far as making the tubes, was fairly not too user unfriendly, but I think my best bet was to not wear gloves at all, at least for this part of it, while that contact cement is drying. If I keep this tape folded over with my fingers, whoops, and then line up the cardboard to the line at both spots. Probably can't see it real well, but I'm trying to get it on the line. Then I can extend that tape from the inside of the roll. Just try it like this. Yeah, it's easier. I can see what I'm doing now. Yeah, I want to get this on the line as closely as possible. Then that tape is normally going to want to spring out, so I can secure it as it does that. And it gets me fairly straight on there. Probably going to have to do this a little bit at a time, and just so I can have something to hold on to as I'm going. I'll be right back. I'm going to get a blow dryer or something. Okay, I'm back. I have sourced a 500 watt on low heat gun, and we're going to try to just accelerate the process a little bit here. Whoa. Don't want to put it on high too much because I'm not sure how much. I don't have the greatest spot for power here. Okay. I'm just going to proceed to try to get this thing to roll up into the best tube possible. May have a slight alignment issue, but luckily it's going to be inside of an enclosure. Okay, I got that far, and I've got this whole piece is coated with contact cement, so all I have to do is go along a little at a time, give myself something to hold on to as I roll the tube up and continue with the process. Not the straightest tube, but this is my first attempt, so. And get to the last part. And it looks like I'll probably end up getting some clear tape or something over that seam, but it's not holding up too bad. I could have went a little further with the glue, but I'll probably just tape it up and then. I didn't do the best for alignment. I'm going to trim that off with some scissors as I go. It's not going to be crucial as far as exact dimensions and everything, but I did go off a little bit, but it's workable, and this will be one of the 3 containers for the capacitors that I need to install inside the box. I'm finding that the small tube, the 3/4 inch one, is not wanting to stay glued together as well with the contact cement. The larger one seems to be doing okay, but I'm going to have to give this one a wrap with some good tape to just to hold it together, because if not, it just wants to come apart on me, and we don't want to let that happen. So. That'll give the glue a good opportunity to set. And And then the one tube that I did make, trimmed up the end a little bit. Didn't come out looking too bad, and what I did is I started to cut and then roll the end over in order to, I can put some hot melt glue just on the inside of it, and then slide a plug in from the bottom, and that could be my bottom plug, and then everything else I can stuff in through the top, arrange the capacitors as I can see fit to make them get in there, and fill up the voids with some fiberglass insulation, and then do the same thing for the top, and I'll have a hole drilled in the center top plug to have wires for the connections come out of, and hot glue all that together, and it should work out pretty good. So I think between these 3 tubes it'll give me enough space to get things done. So I'm going to keep on keeping on here. All in all, I think I've done fairly well. I've got the 3 tubes constructed. I did notice that I did make the 3/4 inch one for the center a little longer, but that's no huge deal. I can trim that one off, and the measurements came out pretty good. I've got 1.5 inches almost right on the dot there, which is comparable to what the other original Dynamite sticks were. So 1.5 inch plugs will go in there very nicely, and just have to continue with my little construction here, but at least the major part of the arts and crafts of this episode is completed. So I can put the lid on my glue and move on to a little more cutting up of things for the plugs, and then the actual construction of the capacitors.